Here we're going to look at two more postulates for proving triangle congruence. This is the ASA, angle side angle, and the AAS, angle angle side. We're going to add these two to our previous two, SSS and SAS, to give our four triangle congruent statements. So what the angle side angle postulate says is, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So angle, congruent, another angle, and then the included side means the side in between them. That would be angle, side, angle, angle, side, angle. The other postulate is the angle, angle, side, which says if two angles and a non-included side, so in other words, the side is not between the angles, of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So here you have angle, angle, and then side. The difference between ASA and AAS is AAS, the side is not between the angles, whereas in ASA, the side is between the two angles. You could have also, instead of putting the congruent side there, for AAS, you can also put it on this side, because you still have AAS, AAS. So we've learned four ways to prove, so let's try a couple proofs out and see how we do with them. For each of these, I'm going to ask you to pause the video and try them, and then we're going to come back and work them together. So go ahead and pause right now. All right, let's mark the picture. Angle V is congruent to angle Y. Sorry, Y should be there, so that might have thrown you off. Angle V is congruent to angle Y. WZ bisects angle VWY, so that makes this angle congruent to this angle. And we also know from the picture that this side is congruent to itself. So, is the side between the two angles? Nope. So we got to use angle, angle, side. So let's go ahead and write it out. Angle V is congruent to angle Y. That's a given. We also have, okay, sorry about that little gap there. We got angle V is congruent to angle Y. That's our given. We also have WZ bisects angle VWY. And that's our given. And finally, of course, we write our reflexive up top that WZ is congruent to WZ, and that's our reflexive property. So I have two angles. One angle, one side. So I need to get something else from this. So WZ bisects this angle. So angle VWZ is congruent to angle YWZ. And that's by definition of bisector. So now I can join these three together, and I can say triangle VWZ is congruent to triangle YWZ. That's how I finish my proof, and that's by AAS congruence. All right, so once again, pause the video and try this one out. All right, here we go. Mark up the picture. It already has the markings for the parallel lines. AE is congruent to BD, and angle E is congruent to angle D. Now, if I have a set of parallel lines cut by a transversal, then corresponding angles are congruent. So it looks like I'm going to be able to use ASA because the side is between the angles on this one. So we have AE parallel to BD, given of course. We have AE is also congruent to BD, which is our given. And finally, angle E is congruent to angle D, and that's our third given there. So by the parallel lines, I know that angle EAC or EAB is congruent to angle DBC. And that's because if parallel, then corresponding angles are congruent. So you'll want to go back and review those parallel line proofs to get those theorems down. And now I join them together, and I say triangle AEB is congruent to triangle BDC by angle, side, angle, congruence. All right, let's look at one more. So pause the video and attempt it on your own, and let's see how you do with it. All right, angle F is congruent to angle H. FG is parallel to JH. Okay, we have two parallel lines. They're cut by a transversal, which makes this angle congruent to this angle. Now, what you need to be careful of is realize that this angle right in here, we don't know necessarily that that's congruent to this from the parallel lines, because we have these extra lines that cut through. You have to make sure that you compare the actual corresponding angles. And finally, you know that JG is congruent to itself. So it looks like we'll be able to use AAS, AAS here, because the side is not between the two angles. So given angle F is congruent to angle H, FG is parallel to JH, and finally, we always put our reflexive side up top. So JG is congruent to JG. Now, from the parallel lines, we learn that angle FGJ is congruent to angle HJG. Sorry, that's a lot of letters. That's because if parallel, then alternate interior. If I said corresponding angles earlier, I'm sorry. It's alternate interior angles are congruent. And now you join them all together, and you can say triangle FGJ is congruent to triangle HJG, and that's by the AAS congruence. So remember, keep practicing these proofs because practice makes perfect on them.